We know that everything in the world, including you and me, is made up of atoms. Every element of the periodic table, and the paper it's written on, is made up of atoms. But what are atoms made up of? Let's look at chlorine as an example.
Every atom of chlorine is the same. A cloud of electrons surrounds a central nucleus. The electrons carry a negative electric charge. But right in the middle, the nucleus is positive, because it contains a number of positive particles called protons. Also in the nucleus are neutrons, but they play only a small role in chemistry. Most of chemistry is about what happens outside the nucleus, what happens to the electrons. If it were possible to see an atom using a microscope, this is what one might look like. Squashed flat, the electron cloud would look like a set of rings called shells. 2 electrons are all it takes to fill the inner shell, but the next one out can hold up to 8. In chlorine it's filled, but the third shell isn't. Again, it's got room for 8, but with only 7 spaces occupied, chlorine has a gap which it is desperate to fill, and that's why it is so reactive.
Here's a quick recap. Every atom has a nucleus at its centre containing positively charged particles called protons. Negatively charged electrons move around the nucleus. Atoms have a neutral charge because there is the same number of protons and electrons, which have equal but opposite charges. Their charges balance out. For credit level, you should know that atoms also have particles called neutrons in the nucleus. Neutrons, as their name suggests, have no charge. Now pause the tape and copy down this table. Once you've filled in the blanks, start the tape again to check your answer. Protons have the symbol P, a charge of 1, a mass of 1, and are found in the nucleus. Electrons have the symbol E-, a charge of -1 and a mass of almost nothing. They are found around the nucleus. And finally, neutrons, which have a symbol of N, a charge of 0 and a mass of 1. Neutrons are found in the nucleus. Although all elements are made of atoms, the elements are all different. This means the atoms of each must be different too. The difference lies in the number of particles the atoms of each element has. The elements are arranged in order of increasing atomic number. The atomic number tells us how many protons an atom of that element has, and this is the same as the number of electrons. As the atomic number increases, the number of protons and electrons increases. The electrons are arranged in energy levels. The data book will show you how the electrons are arranged. The number of electrons in the outer energy level is the same as the group number. This means elements with the same number of electrons in the outer energy level of each atom have similar chemical properties. You should know the following terms which describe an atom: mass number, isotope, and relative atomic mass. The mass number is the number of protons and neutrons added together. They're the particles in the atom that have mass. You can use this knowledge to work out the number of neutrons in an atom. Number of neutrons equals the mass number minus the number of protons in the atom. To write the nuclide notation, mass number and atomic number can be shown beside the chemical symbol for an element, like this. For example, here's the nuclide notation for sodium. Its mass number is 23 and its atomic number is 11. Isotopes are atoms of the same element but with different numbers of neutrons. Chlorine is a good example. Both of these chlorine isotopes have the same atomic number, but they have different mass numbers. The relative atomic mass is the average of the masses of the isotopes of an element. Here's an exercise. Pause the tape and copy the following sentences. Then fill in the blanks. The periodic table is an arrangement of all the, in order of increasing, elements that have the same number of electrons are found in the same. These elements will also have chemical properties. And write down all the information given by this nuclide notation. The periodic table is an arrangement of all the elements in order of increasing atomic number. Elements that have the same number of outer electrons are found in the same group. These elements will also have similar chemical properties. And faced with this, we can tell the element is carbon and its symbol is C. Its atomic number is 6 and its mass number is 14. It has 6 protons, 6 electrons and 8 neutrons. If you didn't get all this information, have another look at this section to revise the parts you're not sure about.
Many chemistry questions ask you to identify the type of chemical reaction taking place. They may say, identify this reaction, identify the chemical reaction occurring here. You need to be able to give these reactions a label, like addition, polymerization, neutralization, combustion. Try to make sure that you can match up these names with the reactions that are taking place.
I found the best thing to do in my exam was to treat it like any normal day. The night before, I'd relax, watch some television, have a good night's sleep and get up and have a decent breakfast and go and do my exam as best as I could.
As soon as you start the exam, I would suggest that every formula, every equation you can remember, get it written down straight away in the back of your sheet. Anything at all that's in your head, just get it down right away, and it would amaze you when you're struggling later on, the time's going on and you're doing your last 3 polar mints and you're really panicking. Anything that you can't remember, flip over the sheet and lo and behold it will be there for you, and that'll be an absolute godsend for you.
For chemistry, an easy tip for remember your diatomic elements is bond shift. B for bromine, O for oxygen, N for nitrogen, C for carbon, H for hydrogen, I for iodine and F for fluorine.